Welcome to Brain Vision.
Hello friends, as shown in the figure, there is a turbine disk having the mass of turbine disk is given 30 kg and its centroidal radius of gyration is 175 millimeter, that is 0.175 meter, and is rotating in clockwise at angular velocity of 60 rpm or 2 pi radian per second. When a small blade of which of weight 0.5 Newton at point A becomes loose and is thrown off. Neglecting friction, we have to calculate change in angular velocity delta omega of turbine disk after it has rotated through first part 90 degree, second part 270 degree. Mass of blade is 0.5 Newton divided by 9.81 meter per second square. It is 0.051 kg. Moment of inertia of remaining portion of the disk about O. It is M turbine into K square minus mass of the blade removed from A into R2 square. Mass of the turbine disk is 30 kg. Radius of gyration is 0.175. Mass of blade is 0.051 kg and its distance is 0.3 meter. So radius of gyration of remaining part of the disk you will get 0.91416 kg meter square. Position of center of mass. So center of mass having the x coordinate m minus ma x var to be minus ma into Ra. Here m is the mass of the turbine. So from here x bar you will get mass of A, R of A upon mass of turbine minus mass of A, for position A1. Theta is 0 degree. Omega 1 is 2 pi radian per second. So kinetic energy T1 is equal to half I/O omega 1 square and potential energy is 0 because it lies at the level of, because center of gravity lies at first part, position 2. Here theta is 90 degree. Suppose angular velocity becomes omega 2. So kinetic energy at this position is I/O omega 2 square. Center of gravity lies a distance above point O. So height of the center of gravity above O will be MA divided by mass of turbine, mass of A. So potential energy we will get B2 M minus MA into G into H. So from here you will get MA into G, substituting the value. Mass is 0.051, radius is 0.3 into 9.81, so 0.150 Newton into meter. Now applying conservation of energy for position 1 and 2. Kinetic energy at position 1 plus potential energy at position 1 is equal to kinetic energy at position 2 plus potential energy at position 2. It is given half I/O omega 1 square. Potential energy at first is 0. It is half I/O omega 2 square. and its potential energy is V2. So by solving this equation for omega 2, you will get half I naught omega 1 square minus V2 substitute the value. Moment of inertia we have calculated 0.91416 or omega 1 is 2 pi minus potential energy 0.150 divided by half I naught. So on solving it, omega 2 you will get 6.25 7016 radian per second. Hence change in angular velocity omega 2 minus omega 1 6.257016 minus 2 pi 3.14. So it will be negative of 0.02 radian per second. This is the answer of part A. Now we have to find part B. For position third, where theta is 270, kinetic energy is half I naught omega 3 square. Center of gravity lies a distance ma Ra upon mass of the turbine minus ma below point O. So here H3 is minus ma Ra upon mass of the turbine, mass of the blade removed from position A. So potential energy at this position you will get M turbine minus ma into G into H3. Substituting the value, H3 is given minus ma Ra upon mass of the turbine. So on solving it, the potential energy you will get ma Ra into G. Mass of A is 0.051 kg. Ra is 0.3 into 9.81. So V3 you will get minus 0.15 Newton into meter. Now applying conservation of energy for first and third position. You will get kinetic energy at first position plus gravitational potential energy in first, kinetic energy in third position T1 is half I-O omega 1 square. Potential energy is 0. Half I-O omega 3 square minus 0.15. So from here, value of omega 3 we can calculate half I naught omega 1 square plus 0.15 upon half I naught. Substituting the value, we will find the value of omega 3. Let us see here. Half moment of inertia about O is 0.91416. Omega 1 is 2 pi radian per second square plus 0.15 divided by half 0.91416. So on solving it, you will get angular velocity at third position to be 6.309246 radian per second. So change in angular velocity, omega 3 minus omega 1 minus 2 pi. So it would be 0.2.026061 radian per second. That's all for it. Thanks for watching it.